Well, good morning, everybody. This is Mrs. Eckert, and we are starting a new unit. Unit 3 is on systems. We're going to call them the 2 by 2 systems, which means you have two equations and you're solving for two variables, x and y. You have had this in Algebra 1, probably spent about a month on it, and then we're just going to kind of review it all in one day and then practice quite a bit on this, so you'll be able to remember everything that you probably did in Algebra 1 and probably do it even a little bit better. So I'm going to enlarge this. We're going to go ahead and start with example 1, letter A. Before I start, let's talk about substitution. Substitution is when we want to get a variable all by itself, and then we're going to take the expression of that variable and put it into the other equation. So you want to pick a variable that has a 1 in front of it. Could be positive or negative, but that way it ensures that you don't get fractions in your expression. I know how you all love fractions. So here we go. I'm going to enlarge this so I have enough room. Okay, so we're going to look at this. I'm going to choose the top equation. And the reason I'm choosing the top equation is because the y has a negative 1 in front of it. So we want to solve for y to get it all by itself. So I'm going to subtract 2x, and then I get negative y equals negative 2x minus 1. We're going to divide by negative 1, so I get y equals 2x plus 1, and that is our expression. We put a box around it. Now here's the key to this one. We need to go to the other equation. So I'm going to go to 5x plus 2. But when we get to this particular point, this is where the substitute goes, and the substitute is the 2x plus 1 equals negative 16. So we're going to have to distribute, so 5x plus 4x plus 2 equals negative 16. 9x plus 2 is negative 16. We're going to subtract 2, so 9x is negative 18, and divide by 9, I get x is negative 2. So that's my first coordinate. Sometimes you may want to go over and just go ahead and write that in. So negative 2, that way you know you're solving for the y. Sometimes people turn in their order pairs and they switch them around. So if once you solve for one, you put it where it goes, then you know where the other one will go. I'm going to go ahead and switch colors just so you can see it around all this stuff. At this particular point, then, we're going to take our negative 2 and we're going to go to the box and we're going to substitute the negative 2 in for the x. So when I do 2 times negative 2 plus 1, I get y equals negative 3, and that is my answer for substitution. So now what we're going to do is we're going to also do elimination, and we should get the same exact answer. So let's kind of go through and let's see how we do here. So here's elimination. I'm going to go ahead and rewrite both equations. So you have 2x minus y equals negative 1, and we have 5x plus 2y equals negative 16. Okay, on elimination, what we want to do is we want to pick a variable, and honestly, that's the hardest thing for a lot of people to do, is they just don't choose the variable. I usually choose the variable that has a 1 in front of it, or have two low numbers that will both go into a low common factor. So if you notice here, our same y has a 1 in front of it. So the goal is to multiply that equation by a number so that both y's have the same number in front, one positive and one negative. So if we look here, if we multiply this top one by 2, that will give me 4x minus 2y equals negative 2. So if you look at your y's, we now have the same number in front, one positive and one negative. So what we're going to do is we're going to add down. So you get 9x equals negative 18. Divide by 9, I get x is negative 2, which happens to be the same thing I got in the other problem, doing it by substitution. Okay, so now what we're going to do is we're going to take the x and we're going to plug it back into either one of our original equations. I'm just going to go ahead and do the 2x. 2x minus y equals negative 1. We're going to put the x in for negative 2 in for the x, and we get negative 1. So we get negative 4 minus y equals negative 1. Then we got to add 4, so I get the opposite of y equals 3. Divide by negative 1, I get y equals negative 3. So if you notice, we had a negative 2 and a negative 3, which is the same exact answer we got by elimination. Now the third thing we're going to do is graph. And honestly, when I ask you to do a problem and I say do it all 3 ways, graphing is not the first way I choose, because your line and my line might be a little bit different. Maybe you draw the line through the top of the points, or I draw it through the top and the middle of a point. Those differences in those angles will cause them not to go where they need to go. So if we go ahead and scroll up to graphing, we know our answer is negative 2, negative 3. Okay, so I'm just going to write that here. I'm also going to put negative 2, negative 3 on my graph. So if you look there, I know both lines should go through that. Okay, so let's go ahead and we'll do the red first. So we'll do 2x minus y equals negative 1. Now, there's 2 ways to graph a line. You can solve and put it into slope-intercept, which is solve for y equals mx plus b. And you have to graph the b, which is the y-intercept, and then you have to graph the slope. That's one way. The other way to do it is to do the x and y-intercept. So for this first one, I'm going to go ahead and solve for y. And then for example 2, I will do the x and y-intercept. So if I solve for y, I get the opposite of y equals negative 2x minus 1. Divide by negative 1, I get y equals 2x plus 1. So we're going to start, this is my b, and this is my m. So we're going to start at 1. We're going to go up 2 over 1, up 2 over 1. Now, as I do that, the other thing I want to do is I could also go down 2 over 1, down 2 over 1. You see how it goes through my blue point. So we're going to, and that is my first equation. Okay, my second equation, why don't we switch the colors, let's go green. The second equation is 5x plus 2y equals negative 16. Subtract the 5x, so I get 2y equals negative 5x minus 16, and we're going to divide by 2. So I get y equals negative 5 halves x minus 8. So we're going to start down at negative 8 on the y-axis, which is my b. And we're going to go down 5 to the right 2. However, if you notice, I don't have enough graphs, so we're going to go the opposite. The opposite of down 5 is up 5. And we're going to go left 2 because that's the opposite. And I end up at our blue point. If I want to get another number, I go up 5 and to the left 2. And we're going to draw it right through there. Okay, and my 2 lines intersect at the point. Let's see if this works. Can you see that? Intersect at that point right there, and the point would be, is the same answer as I got before, negative 2, negative 3. And that would be the answer for the first one. Okay, if we go to the second problem, we're going to go back up to the top. So this time we got 4x minus 1 equals 1, and 5x plus 2y equals 24. Okay, so let's go ahead and start with this one. We're going to go ahead and solve for y again. So I'm going to go ahead and pick the top one. So if I solve for y, I'm going to do 4x minus y equals 1. And the reason I'm solving for y is because there's a 1 in front. So I get the opposite of y equals negative 4x plus 1, and we're going to divide by negative 1. So I get y equals 4x minus 1, and I'm going to put a box around my expression. If we remember now, we're going to substitute the expression into the other equation. So the other equation is 5x plus 2y, but we know y is 4x minus 1, and that equals 24. So if we distribute, we get 8x minus 2 equals 24. 13x minus 2 equals 24. We're going to add 2, so I get 13x is 26. Divide by 13, I get x is 2. So my first part of my ordered pair is a 2. Now, the quickest way to do this is to go up, and we're going to substitute it back into the box. So you get 4 times 2 minus 1, so that would be 8 minus 1, which is 7. So my answer is 2, 7. Okay, so now we're going to do elimination, and elimination should get me the same exact answer. So let's go ahead and scroll this up. Okay, and I'll go ahead and write the problems down. So the problems are 4x minus y equals 1, 5x plus 2y equals 24. Okay, we got to pick a variable. We could pick x. If we picked x, we would want to get a 20. So maybe we multiply the top equation by 5 and the bottom one by negative 4 to get the negative 20. But I'm still going to stick with my first equation. I'm going to get rid of the y. So this particular one, if we multiply y by 2 again, I get 8x minus 2y equals 2. So we get 13x equals, because the y's cancel, 26, and we get x is 2, which happens to be the very first number we got in the other one. Okay, so now 2, though, we're going to substitute it into either equation. I'm just going to go ahead and pick the second one. So 5x, but we know x is 2. Plus 2y equals 24. 10 plus 2y is 24. I'm going to subtract 10, so I get 2y equals 14. Divide by 2, I get y is 7, which is the other part of my ordered pair. So this tells me that, yes, we did substitution elimination correctly because we got the same answer. So then third, I'm going to do our graph. And if you remember, our graph has got to go through the same ordered pair. So 2, 7. We're going to do these two equations by the cover-up method. So you could solve for y, but I'm going to use the cover-up method. So we're going to get, let's change my colors. So the first one would be 4x minus y equals 1. So the cover-up method is I cover up the y, and 4x equals 1 is left, so x is 1/4. Okay, now the cover-up means what you do is you put 0 in for y. So when I put 0 in for y, that term disappears, so I end up with 4x equals 1. Divide by 4, I get x is 1/4. So if we go up to the x-axis and we go over to 1/4, it's going to be in there somewhere. Okay, and I did not graph 2, 7, so why don't we go back and do 2, 7? So it should go up in there. Okay? So now we got to go back to equation 1, and we got to find the y-intercept. So if we look at the y-intercept, that means we're putting 0 in for x. So x disappears, so I get negative y equals 1, negative 1. We divide each side by, I get y equals negative 1. So if we go to the y-axis at negative 1, that would be right here. So if I connect my two green dots along with my blue dot, and that is the equation for the first one. That's not a very straight line. Okay, so let's try our second equation. So our second equation, let's do red, and our second equation is 5x plus 2y equals 24. Okay, if I find the x-intercept, that means I put 0 in for y, so the y term disappears. I get 5x equals 24, divide by 5, I get x is 4 4/5, so it's almost 5. So 4 4/5, which would be right in there. Okay, and then if we do the y, we're going to put 0 in for x, so then 2y equals 24, so y is 12, which would be up here above. So now we're going to connect that, go through that one, and there. That's a little bit better line. So if you notice, the two of the graphs intersect at that point right there, which is 2, 7. So 2, 7 would be my answer for this particular equation. Okay, that takes care of the review over that, but there's a couple things we want to make sure we see. If we go over here to the special cases on the back of your paper, you get a no solution when you graph. When the two lines are parallel, that means they do not intersect. So you get two parallel lines. The intersection is where, the answer is where they intersect. So since they don't intersect, that's a no solution. Okay? The other way you get is when you're doing substitution elimination and the variables totally drop out. So the variables drop out and you get a false statement like 3 equals 0, 5 equals 4. That also is a no solution. Infinitely many answers means every single answer works no matter what because some special things happen. Well, in infinitely many, that means that the line, when you graph it, is going to be the same exact line. So when you do y equals mx plus b and solve each of them, you'll get the same exact equation. Substitution elimination, the variables drop out again, but this time we get what we call a true statement, like 5 equals 5, 2x equals 2x, 0 equals 0. But on this one, there's a special way to write the answers. So you're going to do set notation. You're going to go x comma y and put parentheses around it, and you're going to do a backslash. So it says for every point such that, the backslash is such that, it follows one of the equations. So you're just going to write out one of the equations, and then you got the squiggles. Okay, so if the one of the equations is 2x plus 3y equals 6, then I would put that right there. Okay, the last two we have are story problems, and I'm just going to set these up right now. And probably won't solve them right now because it looks like I'm running out of time in my class. So if we just set them up, it has the story problem steps there. You want to define your variables, set up your system, solve, and then answer the question using the words from the story problem. So if we look at the first one, it says a vending machine that takes only dimes and quarters. So how about x equals the number of dimes and y equals the number of quarters. We know that they contain 30 coins. Well, that means dimes plus quarters equal 30. This is called the quantity equation, how many I have, with a total value of 420. Well, that's where the value actually uses the cost of a dime plus the cost of a quarter, and that equals the total cost. So then at this point, you would do substitution or elimination to figure out what these answers are. And you should get, there are 22 dimes and 8 quarters. Okay? So I did not do the work here. I usually, one thing that I would do, probably would multiply this by negative 0.10, and I would do elimination. So you would have to make sure you multiply each of them by that. Okay, let's go to the last one. The sum of two numbers is 27. So we are talking about two numbers here. Okay, so the sum of two numbers is 27. So let's say x is the first number, and y is the second number. Okay, we know sum means to add, so we're going to add the two together, and we know the sum is 27. It says twice the first, so that would be 2 times x, plus 3 times the second is 75. So you can do substitution or elimination. I actually did elimination. I just went ahead and multiplied this one by -2 and solved, and when I solved, my answers were, the two numbers are 6 and 21. Okay, and that is substitution and elimination. So if you have any questions on the solving of these two story problems, just let me know. We can always do those in class. So enjoy your day.